Friends, today I am building a SwiftUI navigation shell. So I found a few things similar online. None of them did all the things I wanted. So if we start with this goat and I push a flamingo view and then a poodle view and then a gorilla view, I can pop from the gorilla back to the poodle. Then I could push, for example, a turtle and a mouse. And here's where it gets interesting. So two new functionalities. Pop to root. This trash can will pop to root. So I can pop all the way back to the goat. And then I can't pop anymore. So once again, flamingo to the gorilla to the turtle. Now another functionality, I'll do it with the mouse, is to replace the root. And I made this animate a little bit different. So if I replace the root, it's taking the whole nav stack and replacing it with that new thing. And also, these views maintain state. That was something I wanted to make sure happened. So if I push a gorilla and I crank the gorilla to the max, and then I push a flamingo, when I pop back to the gorilla, he's going to stay cranked to the max, and this mouse stayed cranked where he was. Then from the home, I can't pop to the root, but if I, for example, just push a turtle, I can pop right back to where I was. So that's what we're building. And to start, I'm just going to have a blank app, a blank iOS app. If you bear with me for 1 second, I'm looking for these emojis just so I can have them. And we're only going to type these once. So I copied those. You can pick whichever emojis you would like. But yeah, so we're going to start with, we're going to eventually get rid of this content view, but let's just go ahead and build our view model. So file, new Swift file, and this is going to be root view model. And following the rules of SwiftUI, the root view model, the view model always uses SwiftUI, and it is always a class, and it is always an observable object. There's the emojis that I copied. I'm going to be using those in a second. So root view model is basically going to be a list of app pages. And this is going to seem a little bit weird because these pages are going to be represented with these emoji. But bear with me for a minute. It's going to make sense by the end of it. And these can be skinned, customized, however. So we're just going to make an enum called app page. And in a real app, this could be like your login, or your I am not logged in, or I have logged out, whichever thing it might be. So these cases are just going to be these emoji. And this will be also a string enum, so the raw value will just spit out that emoji. And I'll go ahead and get rid of that comment. So the root view model at its core is essentially a var list of app pages. That might be something that initially makes sense, and we'll perhaps circle back to this and change it. But we could think of the root view model as being something that represents a list of pages. So I want to define the functionality that I want. This is how I built this. So if I make some like mark, for example, intents for root view model, one, for example, could be func push page at page. One could, for example, be func pop. One could be func replace root. With an at page. And one could be func pop to root. And those are essentially the four functionalities I demonstrated a bit earlier. Let's go ahead and build our root view. So root view is going to be, oops, shouldn't be a Swift file, it should be a SwiftUI view, root view. And root view is, of course, going to use root view model. So we could say observed object var view model root view model. And then we're gonna almost immediately need, like if we're doing these previews, and I recommend that, like a mock function. So there could just be static var mock root view model, which just returns a naked root view model. And then this preview, we can use the autofix root view model.mock. I'm sorry, I'm a bit of R, not a func. Root view model.mock. And then this is high-level navigation, so I'm going to go ahead and wrap everything inside of a geometry reader that's going to be used to position and move things. So just geometry in blah, and somewhere in there I'm just going to have a z-stack. Just for the sake of getting something showing up on the screen sooner rather than later, let's go ahead and bang out like a little animal view. So one of the things that we can have is going to be this, and this is also a SwiftUI view, animal view. And this is going to be something rather basic. We'll just say let text string. And let's just make the body of this thing be a v-stack with an h-stack in there, and ultimately a text with our text. And let's put spacers around everything. So I'll put a spacer above and below the h-stack, and I'll put a spacer before and after the text. And then this is going to be like a huge animal. So I'm just going to say font dot system size. 120 is the number I picked that looked good. And then down here in this preview we do need text. So I'm going to go back and copy the goat and put the goat where he belongs right there. Boom. Later we can add those sliders and things here, and then just to make this more pronounced, I'm gonna add a little bit of padding. So I'll just say padding all 24, and I'll just say background. I'll make it a rounded rectangle with the corner radius of 20. Fill it, make it some color, perhaps red, but not too dark, so like opacity 0.25. Pretty random. Then in a root view, for now, let's just add an animal view with some text of that goat, and just make sure that something shows up real quick. And that will automatically fill the allotted space. So, oh, you know what? I need to add root view in place of content view. And I need root view model. Oh. I'm going to change this to a var, I'm sorry, instead of a func, so static var mock. So in the app, the main app file, I'm just going to make a global reference to root view model. And this can instead be done as an environment object, but my goal with this is just to have something where I can always access it. I don't plan to have more than one of these in the app, so I don't really view it as anything too evil. So inside of navigation shell app, I'm just going to add root view, and as an argument, root view model. What was this other error we had? Let's see if there's another error. Nope. Okay, so we just get an animal or an emoji inside of a rounded rect. So that just kind of is a fun thing to use for our view. No special trick there. So the concept here, or the idea, is that these views can be pushed and popped and replaced and so on and so forth. So to do that, we want something. What we don't want, I'll tell you what we don't want, is to push a view, for example, into the view model. Like, we definitely don't want to have like func push some view, any view. That's going to create a world of problems for us. So what I've done is, instead of using just a list of app pages, I made another little struct, a little wrapper struct that is an identifiable that can be iterated over with a for each loop. So I'll just go ahead and build that. I'll say struct app page container identifiable. And this is going to have a page for app page. It's going to have translation values, so var translation x cg float and translation Y CG float. This is how we're going to animate. We're not going to move the views in and out of the hierarchy, because then we're going to lose state. Like when I slid those sliders and those sliders weren't tied up to anything in the view model, if those left the hierarchy, we would lose state. That's why I chose to do it this way. So these then are also going to have an ID int, and I'll just make an init for this with page at page. So self.page equals page, and maybe self.translation y equals 0, and x equals 0. For ID, let's just go ahead and make a little ever incrementing number, like at page ID. That can just start at 0. So then self.id equals that at page ID, and we'll increment it. Oh, I forgot to say var, private var at page ID. So now instead of a list of at pages, this is going to be a list of at page containers. And this is also going to be published. So whenever this changes, we want to update our UI. So just to get us started, kind of, let's do a very basic push. So when we push, let's just say let new container equal at page container page. So that'll be the page that we pushed to. And then just the very simplest thing we can do is just say list.append, not contents of, list.append new container. So that'll modify the list and update the UI if we pushed a page. So let's go ahead and add an init. So when we init root view model, let's just push page. I'm going to start with the gorilla in this version of it. So now in root view, this is going to be a little bit more different. So instead of just having an animal view, we're going to iterate over that list. So for each view model dot list, and these are now called container. We need to draw something. So we'll just for now draw animal view, and the text will be container dot page dot raw value. So now when we start, since we have that gorilla, when we start, we should see that gorilla show up. And that is the gorilla. That's coming from the for each loop. So now, this is going to be a bit tedious, but we just have to add that navigation to do all of the different kinds of pushing and popping and stuff. So let's try to do a bunch of that. So I'm just going to go ahead and build a view called control panel view. And control panel view is going to be a huge VStack. Is going to add a spacer to the top of it of about 24. I'll add that same spacer to the top and bottom. Could also be done with padding. Doesn't really matter. So let's just make an empty H stack and just put a little comment in here. This is all of our animals. We need some way to get all of those animals populated there. And then this is the more tedious part, so just the skinning of all these buttons. So there's just going to be another H stack. And there's 4 buttons. So if we just build a button with action label and we could just put clicked 1 or whatever there for now. And for the label, this is going to be our back button. So image, system name. I'm just going to go ahead and copy what I have written. Arrow.left.square.fill .font .system size of 52. And I'll go ahead and put a spacer before and after each button. So the second of 4 buttons is going to be clicked 2. And these come from the SF Symbols app. They just come, you can download it on the internet, SF Symbols. That's all I did is I literally just copied things out of here. You click on one of them and say copy name. But anyway, this one is arrow triangle, blah, blah, blah. So then I need another spacer and button for the third one. And this is the trash. The trash icon, remember, is our icon that pops to root. So it throws out everything except for the root. I thought that might be appropriate. And that one, for some reason, looks better at size 42. And that's clicked 3. Then our final button for clicked 4, let's go ahead and put a spacer at the end of that button. This is to replace the root. So this is house.fill. This one can be a tiny bit bigger, 44. And I'm going to go ahead and make the foreground color of this white. And I'm going to go ahead and take that outer VStack and add a background to it with like a rounded rectangle of corner radius. Oh, let's make it 18 and fill it in. Foreground color. Let's make it black. Oops, dot foreground color dot black. Make it a tiny bit translucent. Why not? Doesn't matter. Then let's just go ahead and get in root view. Let's have a VStack with the animal view and a control panel view. Now what's wrong with that? I just had an extra parenthesis there. Sorry about that. So let's see if that works. It should. Yeah, so there's our 4 buttons. That's going to be one of the most annoying parts of the whole app in terms of just tediousness. Then we're going to need our little thing to pick animals. And I'm going to do this a little bit weird. And it's not for this app. This is for other apps. So each one of these things that gets pushed is going to be an MVVM. So there's going to be a view model associated with it that lives for the entire lifespan of that view. Our goal is to not recreate that view model every time the view has to redraw. So we only want one copy of the view model. So it can be called anything. I'm just going to call these generics. So I'm going to make two things. I'm going to make a generic view. And that's just going to replace that VStack that we already have. And then I'm going to make a generic view model. And view model is going to follow our pattern for view model. So it's going to import SwiftUI. I'm just going to go ahead and copy that name. So say class generic view model, observable object. I think I'm going to need a mock, so I'm going to make static var mock generic view model, return generic view model. And for what we're doing, we could just have our array of animals. I'm just going to put a comment array of animal emojis. And we'll just kind of do a little hack to get that up and running quick. So in root view model on app page, we'll go ahead and make app page be case iterable. And then on generic view model, I'll just say let pages equal app page dot all cases. And then generic view is going to take as an argument or as a parameter or as a member observed object var view model generic view model. And remember, I said this is just going to be a replacement for what we had. So this is just going to be a VStack with the animal view. Yes, but the animal view needs text. So the view model could actually have that text too. So I'll just say let text string. So I can just say view model dot text there. I'm just going to add a little spacer, or actually I won't do it that way. I'll just say spacing 16. And then I'll also add the control panel view. And the control panel view needs a copy of this view model too. So the control panel view, I'm going to give that view model. And then everywhere I've got to add the mock.mock. And same with here, generic view. We need generic view model.mock. And then once the compiler catches up, we're going to need it there too. So we'll just repass the view model. And now in our root view, and I know this is getting a little hectic, but bear with me. In this for each, instead of that vstack, let's just make a generic view. Why is it taking body as an argument? That isn't right. Well, doesn't matter. What does matter is that we need our view model, and we don't have it here yet. So container, well, we looped through container, and I already kind of found out that this is an okay place to put it because these containers live indefinitely until the views leave the screen. So I'm jumping again, but here in @page container, I'm just going to say let view model be a generic view model. And then in the init, I'm going to also pass view model there, and I'm going to assign it self.viewModel equals view model. So we need another weird little private helper here. So private func, I'll just say view model for underscore page @page, which returns a generic view model. And then we can just switch on the page. Or we don't even need to do that. That's one. This would be more practical if these were all different, but we really could just say return generic view model. And they should be taking text as an argument, so page.raw value. So I guess we don't really need to switch on it there. Then here, maybe I can use this autofix. I'll put it here. View model for page. Generic view model cannot be structured because it has no accessible initializers. Well, let's go ahead and add an initializer to generic view model. So we need init text string self.text equals text. And then down here, we can just do text for the mock. We'll go back to our goat, perhaps. Where was that at? That was on... Let's do the turtle. So for that mock, we'll use the turtle. Then back on our root view, generic view with the view model of, now we have it, container.viewModel. And this seems a little bit weird, but this is a way to keep those view models from popping in and out of existence. We don't want to create the view model every time that view is grabbed here. So having it stored outside, in this case, is going to work in our favor. Now, another thing, all of these functions we made on root view model, push, pop, replace root, pop to root, I'm going to go ahead and just add copies of those on generic view model because it kind of makes sense to do it there. And I'm just going to have all of these pipe through to root view model. root view model dot push. So they're just kind of passing through. Root view model dot pop. Root view model dot replace root of page. Root view model dot pop to root. So now in our control panel view, and I've jumped again, but in here I can switch these prints to be what they are. So I can make this say push. Oh, actually I can't because we don't know what we're pushing yet, right? So so we need that little piece too, where we can pick what we're about to push. And this is where maybe this is a little bit tedious, and I apologize. I tried to make this relatively concise. So in control panel view, there's this H stack that says this is for all of our animals. I'm just going to go ahead and add a picker with blank text, and the selection is going to be, I'll just make it say blah. And then in here, there's going to be a for each view model dot pages, and then it can just be I think we need ID there. But the blah, so we actually have to be able to select where we're going next. Yeah, so in here we're going to have a state var, and I'll just call it page equals app page dot. I'll just make them all start as the goat for now. So this blah is going to be cache page, so that's a binding to our page, a binding to our state var. Yeah, and let's just go ahead and do ID : / self. And then in here we need little things to pick. So we'll just say text parameter 0 dot raw value. And let's give it a font of like that system size, perhaps 32. So now when we push, we can print what we're pushing, which is going to be, what did I name it? Page. Got raw value. So now we can also say view model dot push page. Let's try to ascertain whether this is going to work. So when we call generic view model dot push, that's going to call root view model dot push. That's going to make a new container and append it to our list. And our list is published. So as long as root view is updating when view model updates, this whole draw should re-trigger. Let's see if logic pans out. No. Oh, I didn't want this. I wanted a different style. But if I select a poodle, oh, whoops, I put it on the wrong button. But there you go. I pushed a poodle, and then can I push a flamingo? I can push a flamingo. So very, very weird. Yeah, so let's hop back really quick to control panel. And let's make this picker a different kind of picker. So picker style dot segmented. And I'll go ahead and add some padding to like in the horizontal direction of about 24. So that should fix that. Now on generic view, or I'm sorry, on control view still. So this should be pop, not push. And the next one should be push. So I'm just going to say pushed, and then our type of page. I'll just put regular page. So I'll go ahead and fill these all in now. So pop should be view model dot pop. And then click 3 should be view model dot pop to root. I'll go ahead and print pop to root dot dot dot. And for 4 should be view model dot replace root with our page. And I'll just say replacing root with page. Let's see, what else can we do? Just to do a sanity check on this generic view model, let's make it dinit. And whenever this dinits, let's just say deallocated blah, and that'll be our text. So we can see when those view models come in and out of existence as well. We can check it again just to make sure that segment is looking right and the push button is attached to that little play button. Okay, cool. Now we got, it needs a little bit more space. So for whatever reason, spacer on control panel view. Oh, I didn't put the spacing. So up at the top, VStack spacing, I'll just make it say 16. I'll make it 24. But anyway, so if I take a flamingo, I can push a flamingo, I can push a gorilla, turtle, mouse, groovy. So each one of these steps is kind of difficult. So now the next thing that we want to do is to actually animate that. And there's a little bit of an oddity, and there's a bit of a, I am doing something that is a little bit different than you would want to do with SwiftUI, but I think that in this case it's okay, and I've tested it to make sure it doesn't break anything if the stars don't align. But on root view model, we're going to start doing stuff with transition X and transition Y. Now I'm just going to put a little comment that say these go from -1 to 1, ... just to kind of cue us in on that. And then that geometry reader is going to be what actually multiplies it by that -1 or 1 or 0. But if we go into push and we do with animation, we can see which flavors of animation we can do. And none of them, unfortunately, get a completion block. So what I did is I created a version of an animation block with a completion block, and it's a little bit goofy. If you can find a better way to do this, please send me a message. But I'll just make func with animation and completion. And this will be a block of void to void and completion. Something escaping void to void. And all this is going to do is with animation animation dot ease in out with duration. Let's make our duration always be 0.5 block. And then here's where it's real goofy. So I just go dispatch queue dot main dot async after dot now plus 0.5, and that's just a magic number. But there I just do the completion block. And there could even be a little fudge factor, like an extra 0.05. So it seems weird, but if the race condition here fails, and for some reason this executes before this finishes, it doesn't actually hurt anything. But there should be something to properly trap this race condition, and there just isn't. So the next thing I'm going to do is make 4 little helper functions. And these are just going to, or I'm sorry, 5 little helper functions. And these are going to snap one of those app page containers into a position, either to the left, right, top, bottom, or dead smack center of the screen. So I'll make center first, so I'll just say private func snap to center. Whoops. I'll just say cont instead of container. And this will be an in-out because we're going to be reading it from an array at page container. And all that center is going to do is say cont.translation y equals 0 and cont.translation x equals 0. So all these 4 remaining functions are going to be very simple and similar. So snap to left is going to set x to -1. Can you guess what snap to right will do? You're correct. It's going to set the x to 1. Then snap to top, going to set y to -1 and x to 0. And then finally, snap to bottom and set y to 1. So when we push, let's think about it for a second. The first one we don't want to animate because there's nothing to animate away. So if we say if list.count less than or equal to 0, we can just do this, list.append. Otherwise, we want to animate. And what I like to do is I like to give each animation a starting position and finishing position. So I like to snap both of the views that I'm going to animate to their starting position. And then while they animate, I like to snap them to their finishing position. But first I'm going to add another little thing, which is just to know if we're already animating. I'm just going to say private var underscore is animating bool equals false. So in all of these functions, I can just say if is animating return. Maybe I'll print already animating. do a semicolon there. So for all 4 of these functions, I'm going to start like that. And then the user can just click the button again in almost all the cases. So let's go ahead and tell the world that we're animating now. So we can just say is animating equals true. In both cases, we can append this container to the list. So I could move that outside of there. I'm going to put it in both of these just because that kind of makes more sense to me, but it doesn't matter. So the new item that just came on, we're pushing. So we push from the right to the left. So the view comes flying in like that. And the current view that's on the center flies to the left. So the new view starts at the right, flies to the center. The current view starts at the center, flies to the left. So I can use these functions, snap, snap to right, ampersand, list, list.count -1. Remember, these are structs. So these at page containers are structs. We need to modify them in the array. If we don't do that, it isn't going to work. Then also snap to center. We already know that the count at this point is at least 2. So we can confidently say ampersand list.count -2. So that's our initial position. And now we say with animation and completion. Well, that didn't. Maybe that works, but it looks funny to me. Oh, maybe it's because that's closed. So the animation, we want to do snap to left on list.count -2. And this is going to be an in-out again. And we're going to have to put self all over the place here, but I'm just going to type it out like this to make it easier to read. And then snap to center, ampersand list.count -1. List.count -1 is the one we just added. List.count -2 is the one that was the previous top. And then on the completion, I'm just going to say self, or I can just say underscore is animating equals false. So that shouldn't compile, and it's going to be because everything needs self in front of it. So everything inside of these closures needs self, which includes all these references to list. See if that compiles. Woohoo! Alright, so if I want to now push a flamingo, what? Nothing happened. So why is that? Well, it must be because we're changing these translation Y and translation X, but those aren't used anywhere in the UI. So on a root view, we just are placing these generic views. And I'm going to go ahead and kill this old one. So yeah, so here I'm going to go ahead and fix the frame of each one of these things to the geometry size. So the assumption is going to be that everything is the size of the geometry. And that doesn't necessarily need to be there. It's just something I like to do in this type of container case, where everything is essentially the same size. It would just behave weird if somebody tried to put a smaller thing in there, so it'll kind of provide that clarity. But anyway, there's 1,000 ways to do offset, and we can do them any way. So I'm just going to do it the easiest way, offset. And we have container.translationX, and we're going to multiply that by geometry.size.width. And then y, I'll put that on a second line, container.translationY times geometry.size.height. I think that should do it, as long as there's not some other weird thing. Okay, well, you can see the old view flying away, but the new view just appears and doesn't fly away. And of course, pop doesn't do anything, and none of these other ones do anything. So why is that? Let's go and find out. Oh, because to snap to center, this should have been list.count -2. So this is the one that was previously on top. Snap to left, list.count -1, snap to center, list.count -1. I don't think that should fix it, but let's see if it did. I honestly don't know at this point. This wasn't an intended oh, well, that does fix it. So there we go. Cool. We can push and it's animated. And you'll notice none of those deallocates ever got called. Our deallocates are on generic view model, and that's never happened. So let's go ahead and make it happen. So the next logical thing to implement will be pop. And we can go ahead and do that. So on a root view model, pop. Let's think about the rules of pop. So if there's only one element, we can't pop to nothing. This is our root. So this always expects content. So if list.count is less than or equal to 1, we can just return. Otherwise, we're always going to animate. We don't have to do self. We're going to say is animating equals true. And what does pop mean? It's the opposite of push. So instead of this, we have this. So the very top view starts in the center because that's where it is. Snap to center, ampersand, list.count -1. That should do nothing. But if there was, for some reason, that it moved or wasn't finished, that would snap it back to where it should start. And then snap to left is going to be the one that we're about to put onto the top. So list.count -2. And now I'm going to go ahead and copy with animation and completion. And I'm going to make this a little bit neater. Oh, I need to make this an in out too. But yeah, with animation and completion. So the one at -2, the one that's going to be our top, that's going to move to the center. So that's going to snap to the center. And then the other one, our previous top, is going to fly off to the right. And then when our animation completes here, we're actually going to remove one of the items from the list. So we can say self.list.remove last. Let's see if it works. So I've got a gorilla. I'm going to push a goat, pop back to the gorilla. Push a goat, pop back to, and you can see it deallocated. So we deallocated 2 goats. So then if I push a flamingo, and then a poodle, and then another gorilla, and then a turtle, and then a rat, and then a goat, and I clear my log, and I'm going to pop a goat. Let's make sure that works. Pop the goat, deallocated the goat, pop the rat, deallocated the rat, pop the turtle, deallocated, pop the gorilla, pop the poodle, pop the flamingo, and we can't go any further. So no crashes, no oddities. It's just a little bit of a weird way to code that there. So the other ones are similar to these replace root. So I'll just go ahead and do that real quick. It's going to be like push, where we want to build a new container in the same way. So replace root means we're going to do like a super push, basically. And this again is the same thing as push, where if the list count is less than 0, for some reason, maybe we called that first. In that case, there is no animation. We just snap right to it. Otherwise, we're animating. Is animating equals true. And then we can go ahead and do this same code here too. Then for this one, I'm going to have the new view fly in from the bottom. So I'm going to say snap to bottom ampersand list.count -1. So that's the one we just pushed. And then it's going to be snap to center. This is the old king. Now the king is dead. Long live the king. So now, again, with animation and completion, I'm going to just copy and paste. And I'm going to get rid of that list.remove last. But what we want is for the previous king to fly to the top. And then the guy who was on the bottom goes to the center. And then at the end of this, once this animation completes, we only want to keep the very last element in the list. So we can say like self.list equals an array that only contains self.list, self.list.count -1. Let's see if that works. So I should be able to do it just right off the bat. So the goat. We're getting a weird flicker, so I'm going to fix one other small thing. perhaps root view. On that geometry reader, I'm just going to say edges ignore safe area dot all and just be done with it. I want to test this one a couple more times. So if I, for example, if I push a rat and I push a flamingo and then I replace the root with a gorilla, I shouldn't be able to pop. I can't. And those two should have deallocated. So I do see that, well, let's make sure they all deallocate. So if I have a gorilla, I'm going to push a flamingo and a poodle. So there's 3 animals, and I'm going to push a turtle. So those other 3 should all deallocate. And they did. The gorilla, poodle, and flamingo all deallocated. There's only one more. So let's jump to root view model. And that is pop to root. If the count is less than or equal to 1, we could just return. We can't pop to root if we are the root. Then again, we're just going to jump straight into animating. So is animating equals true. And now this one's a little bit different. So what is currently on the top, we want to start at the center, snap to center, list count -1. We'll put the ampersand. But the other one is we're popping all the way to the root. And we're going to move that one to the left. And the root is, of course, element 0. And then I'm going to go ahead and copy this animation block again. And I'm just going to remove that line and twiddle this. So there is no more -2. This guy just becomes 0. But it isn't going to the top. The one at 0 is now moving to the center. The one that was at the top is going to fly to the right. Yeah, because they're popping. I can copy this thing too, so it's going to be like that. So what was at the top flies to the right. What is new starts at the left and flies to the center. Let's see if that works. So I could push a flamingo and a poodle and a turtle, but we always start as a gorilla, so I should pop all the way back to gorilla. And I shouldn't be able to pop anymore. Oh, I can. Well, that's because we didn't finish. Okay, so then in pop to root, after we finish, the list should only have one element. So, and this is self again, self.list equals an array with just self.list, whoops, list 0. And that's it. That is going to do it. Let's make sure. So we start as the gorilla. Let's push a flamingo and a poodle. Let's push quite a few poodles. 3 poodles. And let's do 2 rats. So we should start to see all of those deallocate when we jump back to the root. Yep. All 4 poodles and 2 rats and the flamingo, and we're back on the gorilla. Can we pop more? We can't. We can't pop back to root, but we can push a rat, and we can replace root with a flamingo. The one other thing I'll do is I'll just quickly do like a little magic numbers fix, and I'll show you what would happen if we did this animation wrong, or if our race condition failed. So I'm going to say static let, I'm going to say private static let animation, I'm just going to say dir, make it a CG float, or it could be a time interval, make it a CG float equals, let's make it 0.44, or let's make it 1.0 to really illustrate this. So the duration here will be dir, and the duration here will be dir. But for the completion, yeah, I think it has to be time interval. Oh no, it's just because this is static, so it should be capital self dot. Instead of 0.5, I'm going to make this minus 0.5. So the completion handler is going to get called way before the animation finishes. Well, let's just see what happens in the very worst case. So I'm going to try to push a turtle. I'm going to try to push a flamingo. So nothing really noticeable happens there. What about if we pop? Okay, so you can see what happens. The view disappears, and that's because we're changing list. On pop, we did self.list.remove last, and that happened mid-flight. So basically nothing bad happens other than that little glitch. So I can pop again and I'll get that glitch again. I can push more to, I'll push a 3-pack of gorillas. And then I'll do a home pop to turtle. And we should see the gorilla disappear, flicker halfway up. And it did. So it's basically no big deal. But if I just change that back to, like, I can even make it epsilon, like private static let, like dir epsilon equal 0.05. And I'll just make that self.dir plus self.dir epsilon. So that's basically it. Let's make the duration shorter again. I'll shrink it back down to 0.5. I'm going to go ahead and upload this code to GitHub, and I'm going to post a link at the bottom. And if anybody has any questions or suggestions for improvement, you can reach me. You can send an email to nraptis@gmail.com. That'll be in the video description. Otherwise, happy coding.